Okay, so here there is a classwork. Here you can find meeting link and the tracker. Okay, so if you click on the tracker, you will be able to open this Excel sheet. In this Excel sheet only you guys can access this recording. Okay, so if you people remain absent without informing me, you will not be getting the recording session. Okay, so I think I have given the recording session access for everyone. If not, one second, I'll just check because few candidates have. Jayprakash, you can lower the hands. Yes. Okay, I didn't teach anything technical yesterday. I just thought about the training process for the candidates whoever were present. Okay, and I just told how to access the Google Classroom and everything. Okay, that's it. So from today onwards, the technical training will start. Maybe around 1 month, the training will go on. Okay, so usually as it is from 2 o'clock. Okay, as of now, I have kept for 2 o'clock. Okay, one hour session I'll take as it is still starting. Moving forward, we can increase the duration. Okay, to complete it soon, I will just increase the duration. Okay, we can go like that. Okay, we'll see how it goes. Okay. Okay, well, is it, one second. Okay, just a moment. Where is my cursor? And very important point, those who have not there in the Google Classroom, please do join immediately. Okay, if you are facing any trouble, ping me. Okay, yes. So you people have completed Verilog, right? In the Verilog, both RTL plus test bench, we are writing both coding, means design is also done, plus verification is also done. Now what is a requirement that we are coming to a new subject called system Verilog? Why we need to come? What is the reason? Means there are lot many reasons. Okay, for example, one most important point is reusability. There are many reasons, few reasons I'll list out. Okay, because all of the reasons you will not get to know today. Okay, after 2 weeks you will get to know all the reasons. Okay, now whichever you can understand, those I will explain. Okay, reusability is one main criteria. What happens is, suppose let me take one small any mux project. Okay, so you have written the RTL and you have written the test bench in the Verilog. Okay, after some days, okay, you have made some changes in the mux RTL logic. Okay, now do you think the same test bench will work for the modified RTL? Definitely no, right? How can you reuse? You can't reuse the same test bench. Again you have to write a new test bench, right? But in system Verilog that is not the case. Okay, if you have done any modifications in your design code, whatever the modifications you people have done, according to that you can make some changes in some of the files of the test bench architecture, and definitely the old test bench itself can be reused. That's the most important point about the reusability. Okay, this is the first point that I have explained. Okay, or else any bigger project you can take like a router. Okay, router code will consist of one FSM block, one register block, one FIFO, and one synchronizer. Four blocks are there. Okay, so if you want to verify this in the Verilog, what you will do? For FSM you will write one test bench, for FIFO one test bench, for synchronizer one test bench, and for register one test bench. Like this individually you have to write the test bench, and later on in the top file you have to instantiate all the four blocks and you can pass the stimulus, right? This is not required in the SV. In system Verilog, for the same project we are actually dividing the, see, usually what is test bench? With the help of test bench we are going to pass the stimulus to our RTL, correct? This one function in the system Verilog test bench architecture we have divided, like one component there, one file will do one work, another file will do generation of stimulus, another file will drive the data to the DUT. Like this we have divided the function. So it is very easy for me in system Verilog test bench architecture to write the logic as compared to Verilog, because in the Verilog multiple times I have to write the test bench. In system Verilog I don't have to do that, only one test bench. Okay, but it's not called as one file, we call it as architecture. Okay, that architecture I'll teach today. Okay, so it's a combination of multiple files. Okay, of course, many folders are there, many files are there, but in the organized way we are going to do the functionality. It's not like one file. Okay, see here the disadvantage is, for one FSM we are writing one test bench. Okay, in this particular test bench you are writing everything, passing the stimulus, clock generation, okay, your display statements, everything is written in the same test bench file. But in the architecture it is not like that. Every functionality, every step is divided into the hierarchy process. Okay, so this is one thing. Next, Verilog is module based, right? Which means what? Obviously, whatever is written in module, definitely you can't reuse it, because it will be having a static memory. Okay, but system Verilog is dynamic. Okay, so because we are writing the codes in the class and class. Okay, so it is a dynamic. This is another difference. Okay, likewise many differences are there. Okay, one second. Okay, so here you can see improved test bench capability, enhanced abstraction. Abstraction in the sense your hierarchy only. Today I'll teach what is that hierarchy. Okay, reusability I told. Okay, OOP concept. See, System Verilog is not just one programming language. System Verilog is a combination of multiple programming languages. Ma'am, then like why are we exactly doing this? That I'll tell. Okay, see, System Verilog, what happens currently in the industry, using System Verilog we are actually writing the verification codes only. Okay, but in the down a line 2 years or 3 years, even now also few of the companies like lam research, UST global and all, they what these company people are doing means completely they have removed the verilog. Okay, and system verilog they're using for both design and verification. The reason being is, system verilog is such a subject where, for example, in C language I'm having some concept like loops concept. Okay, that's a very good concept, right, for the programming, right? That particular loops concept I have included in system verilog. Okay, in C++ there is OOP concept, that is a good programming concept topic. Okay, that topic I have taken here. In verilog I'm having task and function, I'm having event scheduler, that is a stratified event queue, right? That is a good topic that I have included in system verilog. Like this, system verilog is created with all the best topics of the programming language. That is why we have more demand for system verilog. If you know system verilog, it means like you know 3 to 4 languages, programming languages. That's the demand of it. Okay, currently in the industry we are for designing we are using verilog, for verification we are using SV and UVM. Okay, but moving forward in the for coming years, verilog will be completely eradicated and only system verilog will be used for both design and the verification. And if you ask me a question that now currently whatever we are studying, is that syllabus relevant for both design and verification, means to some extent yes, but another some 15 to 20% extra syllabus, whenever your company will take that particular step they may provide you the course again. Okay, because currently in the industry and in the market also, SV is used only for verification. SV for design you need to know another some 10-15 days of a course. Okay, maybe in future you may get introduced to it. Okay, yes. So currently whatever we are teaching is system verilog for verification. Okay, because currently how the course is being divided means digital and verilog, this is for designing, and for verification SV and the UVM. Even in the industry also we follow the same, but moving forward we are not using verilog in the coming years, coming in the coming year in the sense after some 2 to 3 years. Okay, now it's already started. Okay, because of the advantage of system verilog, it's already started that few of the companies are starting implementing the design with the help of system verilog. Okay, yes. I think I kept a slide also, just a moment. From here it is. Okay, see, from C and C++, I'm taking data types and OOP concept. From Pascal programming language, I'm taking the assertion topic into the system verilog. From Vera programming languages, I'm taking the randomization and construct topic. Okay, whichever the best topics I'm having. Even from verilog also. Okay, in verilog you people have read so many concepts, all those concepts are still we can use in system verilog also. Okay, means it's a combination of so many languages. It's a combination of so many programming languages. Best topic. Okay, so it's a definition wise you can write like this. It's a unified language for both design and verification, but currently in the industry we are using it only for verification. In future we can use it for both design and verification. Okay, yes, but now itself we can write in the definition that it is suitable for both design as well as verification. Okay, yes. And you can see assertions, coverages, interfaces, all these topics are not there in Verilog. Okay, so and you'll not get to know what is assertion, because assertion itself is 3 days topic for me. Okay, 3 days we will have to explain about the assertion. Okay, so that's why as of now write down the basic points that I'm telling. Okay, later on as the days gets progresses you get to know what are these words. Okay, the difference between functional coverage and code coverage. Okay, completely it is at the end of the SV syllabus. You can open your tracker. I've kept a syllabus copy. Okay, there you can check. Coverage and assertion will come at last. Then you will get to know what is an importance of coverage. Okay, now as of now if I have to tell the difference about code code coverage and functional coverage, means see, code coverage means what? Basically code coverage is related to the design part. Okay, functional coverage is related to the verification part. Okay, now coming to the definition wise, what is code coverage? Suppose in your design code you have written some 100 lines of code. Okay, do you think all the 100 lines will be covered? Definitely no. If I have to give example, if a equal to 1, you have to display some true condition. Okay, or else you have to display some false condition. Just imagine you have a statement like this, you have a loop like this in your design code. Okay, now what happens, depending upon this a value, any one statement will get executed. Am I right? Suppose if it is in the line number 10, this is 11, 12, 13, these are my line numbers. Okay, program line numbers. Now 10 will get executed if a is equal to 0. Just imagine, so 12 will get executed, 13 will get executed, 11 will not get executed, correct? So but does it mean that your code is wrong? No. Getting my point? If code coverage is less, okay, it doesn't mean that your code is wrong. It is just telling that you have written 100 lines of code, in that how many lines are actually executable. That is a percentage of your code coverage. Okay, name itself tells code coverage. How many lines in the code is been covered. That is called as code coverage. Okay, and always this code coverage and functional coverage will be in the form of percentage. Okay, see, basically we are extracting this code coverage and functional coverage once we complete the project. Okay, for example, you people have registered for the course. Okay, why I have asked you people to fill the Google form? So that I can track your performance, I can track your attendance, right, your review marks, and those who want recordings I have marked over there, right? If at all, if I don't ask you people to fill the Google form, how do I get to know that how many students are joining in the live session, right? How many are going through the recording? And I told yesterday that weekly once review will be conducted, right? Then how do I get to, if I do not collect your names, then how I get to know that Sheetal performed well, Gopi didn't perform well? How do I get to know? Getting my point? After 1 month, if management is asking me to update about the status of the or about the performance of the batch, how do I remember? Because there are lot many students, more than 20 students are there. How will I remember the names? It's not possible, right? It is like one particular mark sheet or the metrics on which I am actually giving the update to the management. The same way, code coverage and functional coverage, it is like at the end of the project. Almost once you complete the project, we are going to check all this, that how much code coverage is there, what is the percentage, how much functional coverage is there. And again, there are types of code coverage that we will discuss when I'm telling about the coverage topic. Then I will discuss in detail. Okay, and remember, if you have less code coverage, it definitely doesn't mean that your code is wrong, because the logic itself is like that. Okay, see, definitely this statement won't get executed, but is it like your code is wrong? No. Getting my point? And when I teach the types of code coverage, then it will be clear for you people. Okay, as of now, definition wise you guys can write it down, that code coverage means how many lines in the code is been covered. That count percentage is called as code coverage. Now functional coverage means what? As I told, it is related to verification, which means what? Our test bench. Now, test bench is passing the stimulus to the DUT. Okay, just imagine in the DUT we have written a logic like A equal to B plus C. Okay, so for B and C, I'm going to pass the stimulus like 0, 0, 0, 1, 1, 0, 1, 1. So I have passed how many stimulus? 4 stimulus. Now I have to track it. No, see, it is just 4 stimulus. Okay, you can, and all the 4 stimulus will be sent here and you will be getting the answer. That's fine. But in the industry, thousands and thousands of stimulus will be there. Then how do I track? Means if I send 100 stimulus to the DUT, how do I get to know whether all the stimulus have reached the DUT, yes or no? Whether for whatever the stimulus I have sent, whether I'm getting a output, yes or no? How do I get to know? With the help of functional coverage. Okay, with the help of functional coverage, I'm going to track the stimulus that I have sent to the DUT. Whatever the stimulus I have sent, all those stimulus has to reach to the DUT and I have to get an output. This track performance I'm going to check via functional coverage. Okay, means functional in the sense it is going to check the functionality of the design. How it is going to check? With the help of the stimulus that I have sent. Okay, so functional coverage is going to validate the behavior or check the functionality of your DUT. That's your definition. Okay, yes. So actually for writing the code coverage, you don't have to write any extra code, but for functional coverage you have to write something called cover group. That is a piece of code. It's a small snippet. Okay, how to write the cover group we will discuss in the end of the syllabus. Okay, now I'm just telling what is the difference between the code and the functional coverage. Okay, as of now you just have to make a note of 3 points. First is code is related to the design part, code coverage. Functional coverage is related to the verification part. Second point, code coverage, even if you get a less percentage, that's not a problem. Okay, because the logic itself will be like that. But functional coverage you have to get 100%. Okay, you have to get 100%, then only we can wind up with the project. Okay, third point, in the code coverage definition you can write. Okay, so that how many lines of code we have written. Okay, means about we have written, if we have written 100 lines of code, how many lines are executable, that count percentage is called as code coverage. Functional coverage means with the help of functional coverage we are going to track the performance of our stimulus, or we are going to track the performance of the DUT with the help of stimulus, or we are going to validate the behavior of a DUT. Any of this definition is fine. That is called as functional coverage. Okay, and functional coverage always it should be 100% for sure, because see, if you have sent 4 stimulus, I expect that DUT has to give me the output for all the 4 stimulus, right? It is not like only for 2 stimulus it is giving, for another 2 stimulus if it is not working, then my DUT might be wrong. Okay, so that we are supposed to check it. Okay, and one more, fourth point also you can write that for extracting the code coverage we no need to write any extra code. Okay, we don't have to write anything extra. Only in the I will show it in the Questasim how to extract the code coverage report. I will show it directly with the help of a tool. We can extract the report. But whereas in the functional coverage we need to write some small snippet called cover group. Okay, how to write that cover group I will teach at the particular topic. When I'm speaking about, when I'm teaching about the coverage, then I will explain about how to write the cover group. Okay, yes, make a note of all these points. Okay, and as I told you, people have to write the running notes also, not in the live session. Maybe when you are watching the recording session you can write a running notes, because as I told yesterday, system verilog and UVM is such a subject where explanation matters a lot. Okay, and weekly once you will be having a review. Okay, those who are not attending the review, again they have to take a permission to join the session, a live session, plus even to get the recordings also. Okay, yeah, next, that's what hierarchy structure that we do not have in Verilog. In the system Verilog, what hierarchy structure we have, I will tell now. There is one topic, test bench architecture of system Verilog. Okay, that's very important interview question. How to answer that particular question, I will tell. Okay, yes, and system Verilog can further be integrated with UVM also. Okay, now why to go to UVM when we have SV, that we will tell in the UVM subject. Okay, so we can do the means we can collaborate the system Verilog with some other programming concept also, that is UVM. See, UVM is not a programming language, that is just one methodology. Okay, this also you guys can make a note, this is not programming language. Okay, In the UVM also we are using System Verilog programming language itself. Okay, so please make a note of it. Don't get confused. System Verilog is a programming language. UVM is not. UVM is not at all the programming language. That is just a methodology. That how best I can use the System Verilog. That particular concepts we are going to learn in the UVM. Okay, and DPI is also another topic. Okay, that if you want to communicate, System Verilog can communicate with C++, means external programming languages. That particular topic is called as direct programming interface. Like for example, you have a Verilog file. Okay, can Verilog file communicate with C file? It's not possible. Okay, but with the help of System Verilog DPI mechanism, it is possible. Okay, all these are the reasons that why exactly I'm coming to System Verilog. Okay, in this assertion, randomization, all these interfaces. Okay, so all this it's a separate topic. Okay, see, interface it will take 2 days for me. Assertion, another 2 days. Okay, coverage is a separate topic again. Functional coverage will take 2 days and code coverage 1 day. Like this, each topic we will discuss in detail. Then you will get to know. Okay, as of now, whichever the easy points you have, that you guys can make a note. Okay, yeah. So this is the first question. Okay, they will ask you in the interview that what is the difference between SVA and Verilog, or they may ask you. One second, let me make a note here. Okay, so today's interview questions. See, the same way you have to please explain. Okay, so the difference between are we why are we choosing SV? Okay, one moment. They may ask like, what are the advantages of SV? For all these questions, same answer. Okay, what are the advantages of SV, or what are the disadvantages of Verilog? So Verilog. For all these questions, you are supposed to answer the same answer, which I explained just now. All these. Okay, and even they may also ask you the features. Suppose if they ask you the features of SV, kept that in the next slide. Okay, so here processes, task and function, classes, constraint, clocking block, assertion, coverage. Just now I told assertion coverage itself will take 2 days to get the explanation completed. Okay, all these are the topics. Okay, some 4 to 5 topics you can memorize. Okay, main important topics I'll tell. The randomization you can tell. Features, under the features, assertion, coverage. Okay, yeah, this is enough. This much you can tell. 3 points, main importantly 3 points. Okay, these three are separate topic only. Okay, that's why I'm not telling anything in detail here. Okay, yes, features here only you can add. Okay, because randomization, assertion, coverage is anyways not present in Verilog. Okay, so this comes under features. This also comes under the advantages. Okay, yes, so I hope so it is clear for you people. Okay, difference between Verilog and SV. Why are we choosing SV over Verilog? What are the advantages of SV, or what are the disadvantages of Verilog, or features of SV? Any of this question they ask, your answer will be same. Okay, so from today onwards, please read the topic on that day itself. If not, moving forward you will face difficulty. Okay, because how I'm going to teach the project means step by step I'll teach the project. It takes time. Okay, definitely it takes time. So practically you will be having lot of work to do. That is why theoretical concepts don't keep pending. Okay, on that day itself please study. Okay, yes, and you have to write the running notes. It's not like I'm not providing material. I will provide the material, but don't depend on the material, because explanation, see, I what explanation I'm giving in the live, that will not be present in the material, right? So that is why how I am explaining, the same way you can write down the notes. Okay, yes, and here you can see the SV references, LRM textbooks. Okay, if you want you can verify this, refer this website if required, but it is actually not required because I'll provide everything as I told yesterday in the demo session. Okay, the live session codes, recorded this one practice codes, everything I'll provide. Okay, so that you do not have to worry. Even this textbook, everything will be posted in the Google Classroom, which you can download also. Okay, how to download the materials, that also I have informed yesterday in the session. Those who people were absent yesterday, many of them were absent actually, please watch the recording. It is just around 20 minutes. Okay, so please watch the recording. Any doubts if you have, get back to me. Okay, yes. Now, the very important question and 100% question, that is System Verilog. Explain System Verilog test bench architecture. So this question is very important. Okay, so whenever you sit for the interview, if they start System Verilog, the first question will be this question only, architecture question. Okay, so today you are learning only two questions. So first question I explained, second question now I'm explaining. Okay, so before going to this diagram, first let me draw my diagram so that explanation will be clear. Okay, how to tell this answer means, first 3 points I'll give. One is, you people have to list out the hierarchy. Second, you are supposed to explain about the communication flow. Third, you are supposed to tell about the connection. This is how exactly the question should be answered. It's not like simply, randomly you can't answer this question. Okay, this is the flow, in this order only you are supposed to answer. Okay, first, hierarchy. What is that hierarchy? See, in System Verilog, I told that we are having an hierarchy right now. So what kind of hierarchy we are going to follow here? One second. So we are having a top. Okay, you can't leave the session without my information. If you're okay, DUT or DUV or design code or RTL, all these are same words. Okay, design under test, design under verification, your design code or register transfer level, whatever you call, all these are similar words. Okay, so it is written in which language? Verilog. Okay, DUT is written in the Verilog. Test bench, how we will write? Now we will write in a System Verilog. Okay, test bench, I will be writing in a SV, which means what? Test bench is a dynamic. Okay, so this DUT I have written in the Verilog. So Verilog is what? It's a static. Okay, in the dynamic means what? The data will be in the form of packet level. In the static, the data will be in the form of pin level. Okay, as of now, make a note of this. Now, inside the test bench, we are having test. Inside the test, we are having env. Inside the env, we are having transaction, generator, driver, input monitor, output monitor, scoreboard. So this is the hierarchy. Okay, and between the test bench and the DUT, we are having an interface. It is not a file or component, it is just like a bridge. I'll tell what is the use of it. It is an interface, or specifically if you want to tell, you can tell it as static interface. First, this is what you have to tell. That is what is called as hierarchy. Okay, it's not like you can't tell, like we have in the System Verilog test bench architecture, we are having input monitor, test, DUT, scoreboard, transaction. No, completely that's a wrong answer. You have to follow this hierarchy. Okay, top, inside top, test bench and DUT. Inside DUT, there is test. Inside, see, I'm using the word inside. In the same way, you have to explain. Inside test, there is an ENV. Inside ENV, we have again the same flow you have to follow. Transaction, generator, driver, input monitor, output monitor, scoreboard. This is the hierarchy that you people are supposed to tell. After this, we have to go to communication flow, means how and where. Usually the work of test bench is to generate the stimulus, right, and to give that stimulus to the DUT right now and collect the output. So who, which component, which file is doing which work, which file is doing which functionality, that we have to explain. That is what is called as communication flow. In the coding, in the project, I'll teach you people how to, what exactly will be written in the test and env. As of now, for the explanation sake of communication flow, let us start from transaction. Okay, in the transaction we are going to write the randomization concept like okay, you can write randomization concept. Okay, means what? In the transaction file we are going to declare the input signals. We are going to declare the input signal, and that input signals we are going to declare it as rand, either rand or rand c. Ma'am, what is this rand and rand c? Again, that is coming under the randomization concept. Okay, see, rand or rand c. Make a note like this as of now. Okay, in the transaction file we are going to declare the input signals, because input signals only we are going to pass as a stimulus, right? Output we don't need. Okay, we need to pass the stimulus, that is input signal. So in the transaction file we are going to declare the input signals, and we are going to declare it as either rand or rand c, and we will write the constraints if required. Constraints if required, this complete topic it will and maybe next week you will get to know this randomization, how to write the constraint, what is randomization, what is rand and rand, how to have a control over the randomization concept. All this, it's again a separate topic. Okay, here it's a theoretical explanation, so I'm making you people to make a notes like this. Okay, so make a note. Here we are going to declare all the input signals, and for those input signals we will declare it as rand or rand c. Okay, and we will write the constraints if it is required. Then are we going to generate the stimulus here? No, we are just declaring the signals, that's it. We are not generating the stimulus. In the generator file we are going to randomize the transaction file, and in the generator file only the stimulus will be actually generated. After that, the stimulus is now generated, correct? This stimulus will be sent to the driver. See, generator is having two works. One is, first point is, it is going to randomize the transaction file itself, and it is going to generate the stimulus. Once it generates the stimulus, that stimulus will be sent to the driver with the help of mailbox. Mailbox, there is something here, another concept called mailbox. With the help of mailbox we are going to send the stimulus from the generator to the driver. Now what driver does? Driver is also having two functions. Driver will collect the stimulus from the generator, and driver is going to drive the stimulus to the DUT with the help of interface, static interface. Okay, means via which medium you are driving, means via static interface medium you are trying to drive the stimulus from driver to DUT. Now again here there is a problem. What is that? See, as I told in the test bench, the data will be there in the packet format. In the DUT, data will be present in the pin level, right? Then who is going to convert packet to pin level is driver only. In the driver we are going to write a logic in such a way that the packet level of stimulus will get converted into the pin level, and then it will be driven to the DUT, so that the DUT can understand whatever the stimulus we are passing. Okay, now I have driven the stimulus. Now I have to collect the output. Now who is going to collect the output? Output monitor is going to collect the DUT output, and output monitor is the one who is going to send that DUT output to the scoreboard. Now why I am sending to scoreboard? Because in this scoreboard I want to do the comparison between the expected output and the output that I have got, that is my actual output, actual DUT output. I want to do the comparison. Okay, now I have got an actual output from the DUT. I have collected the output, and that output I have given. Now what I want? I want expected output. No, suppose the logic here is A equal to B plus C. Stimulus that I have passed is 0, 0, 0, 1, 1, 0, 1, 1. 4 stimulus I have passed. Being a verification engineer, I also know what stimulus I have passed and what output I must get. I should be aware of that, correct? So what I'll do, in the input stimulus I will collect the, in the input monitor I will collect the stimulus either from the driver or from the interface. I have two options. Okay, collect the stimulus either from the driver or collect the stimulus from the interface, because interface is also having a stimulus, driver is also having a stimulus, because driver has sent the stimulus to the DUT via interface, correct? driver and interface, these two files are anyways having the stimulus. So now input monitor, it's their choice. They can take a stimulus either from driver, they can take a stimulus either from interface. They have to take a stimulus, and what is their work now? They are supposed to write a dummy DUT logic so that we can produce the expected output. That I'm trying to tell to the scoreboard that see, these are the stimulus that I have passed it to the DUT, and in the DUT there is some logic like this, and my expected output is so and so. I have to send that. Now, when expected output and the DUT output is getting matched, then our project is successful. This is the hierarchy. Okay. Now, ma'am, I do not want to write the dummy DUT logic in the input monitor. Means, okay, you can just collect the stimulus and you can take another block called as reference model. Okay, reference model. That expected output is also called as golden reference values. Golden reference values. Okay, which means what? I know what are my expected output, I'm aware of it. Okay, that is also called as golden reference values. So the dummy DUT logic you can write in the reference model also. From the reference model you can send it to the scoreboard. That's your choice. Okay, but usually not required to take extra, it will become again an extra file. But if you want to keep it really very organized, you can take a reference model also. Okay, input monitor to reference model to the scoreboard. End of the day, scoreboard should be having two things. One is expected output, one is the DUT output. Okay, I repeat again, the communication flow starting from transaction. In the transaction, we are going to declare the input signals as either rand or randc. That is, we are going to declare it has rand and randc. Why? Because I just want to randomize it. Okay, I want to generate the random values for the input signal. That is my intention here. Okay, I still didn't generate, I'm just declaring. Okay, and upon that, if we want to write a constraints, we will write. What is that constraint means? Okay, in brief I will tell, because one second, if I don't tell it will not be so clear. Just a moment. Transaction class, I will write class, and class, suppose if you take multiplexer. Okay, some mux, I will write mux underscore t, transaction class. Okay, so input, I'm having I0 I1, 2:1 multiplexer. Okay, I0 I1 select line, these are my inputs. Okay, so what I'll do, I will declare like this: rand rand c. I will declare. What happens if I declare like this? Means this I0 I1 and select line are now selected to generate the random values. Okay, for I0 some random values will get generated, for I1 and for select line some random values will get generated. Now what is that, what is this rand and rand c means? If I declare it as rand, and if I want to generate 5 values for I0, so if I declare rand, okay, for example, first time I may get 1, second time also I may get 1 only. Means there is a possibility of repetition of the values in rand. Suppose if I take rand c, and for select line it will not repeat. Means if I want to generate 2 random values for select line, okay, just imagine like this. Okay, or else let's not take multiplexer, let me take some variables a b c. Okay, so for a I want to generate 5 values, 1 2 3 4 5. A is declared as a rand, correct? No, so when I want to generate 5 different values, I may get 44, 45, 100, 200, and there is a possibility that I may get the same value once again. Okay, this type of values I don't want. I want unique values. Okay, like 45, 44, 100, 550, something like this. Okay, if I want to get a unique numbers, then I will go for rand c. That's it. That is the difference between the rand and rand c. But by just declaring like this, you will not get an output. Okay, I am just declaring, that's it. For which particular input signal I want the like this repeated values, for which particular input signal I want unique values, I'm just declaring it, that's it. Okay, where the generation will happen, generation will happen in the generator file only. Okay, and upon this, if I want to add any conditions for this randomization process, if I want to add any conditions like okay, for a I want to generate 5 values, but that 5 values should be greater than 100. like any value, but it should be greater than 100. 101, 501, two, and 1000, something like this. Okay, whatever the values are getting generated, random values, those values should be greater than 100. So this is one of the condition that I'm implementing, correct? These type of conditions are called as constraints. Constraints. Okay, so that's why I told this is again separate topic. Okay, all this we are actually writing in the transaction. After that we'll come to generator. In the generator, the transaction file will get randomized, and here only actually the generation of the stimulus will happen. From here, the stimulus will go to driver via mailbox. Okay, and driver is going to convert the packet to pin level, and it is going to drive the stimulus to the DUT with the help of interface. DUT is again sending the output to the output monitor. I mean, output monitor is collecting the DUT output via again interface. Okay, and it is going to send the output to the scoreboard. How? Using mailbox again. Whatever communication we do within the test bench, we are using mailbox. Okay, so that's the third point, connection. Okay, outside the test bench, whatever communication we do, we are using the interface. Make a note of this connection, third point also. Okay, and yeah, input monitor, what is the role of input monitor? It is going to collect the stimulus either from the driver or from the interface, and it is going to generate the expected output, so that in the scoreboard I can make a comparison between the actual DUT output and the expected output. Then if the both the results are true means, sorry, the both the comparison is successful means, then only my project is successful. Okay, this is about the second point. The third point, I have actually three things. One is mailbox, one is static interface, which I just made a note here. This is static interface, and within the test bench architecture, whatever the communication we do using mailbox. Okay, another word is there, that is we, nothing but virtual interface. Now what is this? I'll explain again. Now, see, transaction to generator, actually here no mailbox is used, just randomization is used. There you will understand what is happening between transaction and generator. Generator to driver, we are using mailbox. Okay. Monitor to scoreboard, we are sending the output, right? We are using mailbox. Okay. Input monitor to scoreboard, we are sending, right? We are using mailbox. Okay. Everywhere, whatever the communication you want to do within the test bench, inside the test bench, always we go for mailbox. Now, the moment you want to send the data outside the test bench, we use the static interface. That is fine. Now, there is one problem. What is that problem? Now, okay, so you're sending the data. Here, see, when you're receiving the data, I told driver is actually converting packet to pin level, and it will send the data. That's fine. And here, the same way, monitor, it is going to convert pin level to packet level, and it will take. Okay. But see, it is a DUT is a static, interface is a static, this is also static, this is also static, but test bench is a dynamic, correct? Then how the dynamic environment will accept the static data? How it is possible? See, just imagine I have some gate here. Okay, one second, I just have some gate here. Okay, it's a completely, this upper part completely, it's a dynamic. Okay, below two things, one is my DUT file and my static file, both are static. Now how the data will be, how I can take the static data into the dynamic environment? It is not possible, correct? So what I will do means, see, I have to use interface, I don't have any other option, but that interface is static. Now I can't convert that static into dynamic, but what I can do is I can take one small pointer or a small handle called as VIF. Okay, so actually static interface is a file, but VIF is just a pointer, that is dynamic pointer. Dynamic pointer that is pointing to your static interface. Now, where I am going to declare this VIF? I am going to declare this VIF in the driver and in the monitor. Why only in these two files? Because these two files are only communicating with the DUT, right? So only in the output monitor and the driver we are going to, not only these two files, whoever wants to communicate with the DUT, in that particular file I will be declaring this dynamic pointer. With the help of this dynamic pointer I can allow my signals to come inside now. Getting my point? Okay, see, you are from I am from Bangalore. Okay, maybe you are from Hyderabad. Okay, when I go to Hyderabad, maybe I just imagine I do not know Telugu. Okay, then I need one translator, right? That is known as VIF. Okay, so that is how it works. Okay, so this is a static, this is also static. Of course the conversion is happening, that's not a problem. Pin packet to pin level, pin to packet level conversion will happen. But the thing is completely that conversion not a problem. But here I'm speaking about the problem of dynamic and static. Okay, that static nature has to get changed. That change will happen with the help of VIF. With the help of VIF only I'm going to drive the data and I'm going to receive the data from the DUT. Okay, static interface is a file, virtual interface is just a handle that is pointing to the this particular static interface file. Okay, VIF is a dynamic pointer or dynamic handle which is used in those files which files are actually communicating with the DUT. Okay, again important question with respect to interview. They will ask you, tell me what is the difference between the static interface and the virtual interface. Okay, yes. So these 3 points you are supposed to explain to the interviewer when they ask about the test bench architecture. Okay, yes. So is this clear? Just reply in the chat box. Any doubts here? Everyone please reply in the chat box. Test bench architecture, is it clear? Once again I want everyone to watch the recording and make a notes. You will not get this explanation in the website or in the material. That's why I'm asking you people to make a notes. Okay, when I take a review I will be expecting the same kind of answer from you people. Okay, yes. Okay, any doubts if you have, you guys can ask me. Okay, so that's it for today. Okay, so only okay, it's already 3:12. Okay, so let's stop the explanation. So here I have made a note. Interview questions also every day. On that day itself I will give. It's not like at the end of the course I'll not give. Every day once I explain the concepts, what important questions are there, then itself I will tell off. Okay, so please make a notes according to that. Okay, yes. At the end I'll not tell once again. Okay, every day once I complete, here itself I'll tell what are your interview questions. Okay, yes. And here you can see the diagram. Okay, one second. Let me show this as well. Here same thing, whatever I've explained, the same thing you can see here. Program block means, okay, you can write it as modular program. It's a top, I mean. One more extra layer should come here. In the diagram, it's not there. Top, inside top, test bench. For test bench, they have written it as program block. Okay, you guys can write it as test bench. Inside test bench, there is a test file. Inside test env. Inside env, transaction generator, driver, input monitor, output monitor, scoreboard. Okay, and there is a static interface. Okay, version interface they have not shown, but it will be present when you do the coding. You will understand. Okay, and here is a DUT. You can see here it's a pin level, it's a packet level of data. Okay, and here you can see dynamic. All these files are dynamic. Okay, so what all functionalities are, and you can see where and all mailbox is utilized. And see, input monitor is having two options. One is this line, one is this line. It's left to the input monitor, whichever the line it wants it can take. Means it can collect the stimulus either from the driver or it can collect from the interface, anything as per its choice. So this BFM is not there, just you can remove that. While editing I got that diagram here. You can just delete. BFM means bus function model. That is actually the word for the driver. Okay, but now we will not use that BFM word, it is eliminated actually. Okay, you can use it directly driver only. Driver's other word is BFM, bus function model. Okay, yes. And you can see reference data, DUT data, I mean outputs, expected output or golden reference output and the actual DUT output, both are been compared in the scoreboard. If you want here you can take reference model, extra component. Okay, mailbox interface, all this you can check. Okay, see, interface is something that is between the test bench and the DUT, and this is specifically a static interface. Okay, static and dynamic words should be very clear, guys. Okay, so please write my diagram what I have written in the other slide. Here I have just scribbled it. Okay, but you can write it properly. Okay, yes. So I'll stop the session here. Okay, so for those who have opted for the recording session, I'll provide it, and those who are present in the live session, even for them also I'll provide the recording session. Okay, but those who are absent, they have to take a permission. Okay, so even those who people are present currently in the session, make sure if you want leave, ask me. Okay, yeah. Okay guys, so thank you, we'll connect tomorrow again, same timings only, around 2 o'clock only. Okay, anyways I'll tell the timings. Okay, yes, thank you guys, thank you.